We will watch a video to understand the first energy. Okay, uh, getting back up. So now you have an idea how an physical energy can be converted into an electrical energy. The way of conversion depends on the type of sensor, right? And now today we will see what is our agenda is. We will have a glance on what is sensor, what is the role of your front end electronics, and light on what is digital signal processing, what do you mean by data transmission, choice of channel, what is backend data analysis, and how you package and deploy your IoT. Then what is the power constraint in an IoT device, right? We start with sensor. Okay, what is a sensor? A sensor detects a physical quantity and represents it in an electrical signals. That's what we have seen. So what could be the physical quantity, right? What are all the physical quantity you have? Uh, I have to shift between your chat box so you can unmute and give the response. What are all the physical quantity you have? Why no response? What are all the physical quantity? Length, mass, heat. Okay, see, as I'm giving presenting, it's difficult for me to view your chat box, so either you can unmute and tell me, right? Okay, you were right. There were many answers. Okay, pressure variation, Satish, temperature, Kirtika. Yes, all this are your physical quantity, right? Okay. Now, So it detects that physical quantity and represent it in an electrical signals, and how it does its conversion depends on the type of your sensor. So we will see the type of sensors in elaborate in your second module, but just now we will see what are all the type of sensors you can have based on it, how it measures your electricity, the moisture, the sound, electrosonic, vibration, temperature, and pressure, right? These are all some types of your sensors, right? Now we will get into the second part, that is front end electronics. The conversion of your electrical energy into a form that can be readable by your microprocessor, right? So first we will see it as a story, and then we will get into the concept, right? The very first thing is why I want to convert this electrical energy into a digital form. You can give your answers in the Jamboard or in the chat box. Why I want to convert electrical energy into a digital form. Okay, good. The machine can understand only zeros and ones. In digital form, it is easily understandable. Good. Binary language is only understandable by device. Yes, you're right. If I want to pass it to my processor, right? It could be a microprocessor or microcontroller. If I want to pass it, right, I should be, if I want to pass it, then it should be in a digital form, right? Okay. How this happens, that is what we are going to see. How it happens. I have measured the physical quantity, and now I have an electrical signal in my hand, right? This signal is a weak signal, right? This weak signal, I cannot directly pass it to my if I, okay, we will come in a reverse one. If I want to give it to my microprocessor or my processor, I have to convert it into a digital form. So for to perform that, I have an analog to digital converter, right? Okay. Can I directly apply this electrical signal into analog and digital converter? It is not possible because it will be a weak signal. The signal generated from the sensor will be a weak signal. So what I'm doing, I have to amplify the signal. Okay. Can I amplify it directly? What will happen if I amplify it directly? You see, in general, you will have noise in your signal. So if I amplify it directly, the noise will also get amplified. So what I do is, I filter the noise, then I amplify the signal. What is amplification? What is amplification? Amplification is nothing but increasing the strength of your signal, right? Increasing the strength of your signal. So what I do is, from the sensor I get a weak signal, right? From the signal I just filter the noise, then I amplify it, then I give the amplified signal, that is the signal that is rich in strength, is passed to my analog to digital converter. In the analog to digital converter, this signal will be converted into digital form based on the voltage, right? And this digital information will be passed to my microprocessor for further processing, right? This is the story. Do I want to repeat it, or I can move to the slides to see one by one? You can post it in the chat box so that I will proceed. Why I want to spend more time on here is, this is the basics. For some people, this may be so basic, but it is not for all the people. So I just want the opinion. Okay, good. And even when I proceed, if you have any doubt, you can stop me at any point of time by just unmuting your audio. Okay. So in the front end electronics, the first comes your sensor. As we have seen, the sensor will measure the physical quantity and it will convert it into your electrical signals. Then what happens next? Then this electrical signal is passed to a filter. What the filter does means it removes your noise, right? And it gives you the original signal. You have types of filters, low pass filter, a high pass filter. I have given a low pass filter. What is low pass filter means? You set a frequency, right? Um, the filter will allow the range of signals having frequency less than the threshold. I'll tell you a simple example. If I set the threshold value as, see, this is for literal understanding. If I set the threshold value as 45, all the numbers below 45 will be allowed. That is how you set a range for your frequency. The frequency below the threshold will be allowed. All these things we will see in elaborate in communication. Okay, this is filter. Now it is, I have removed my noise. This is the symbol for your amplifier. So what the amplifier does means it just improves the strength of your input signal. Whatever you give it as an input, it will increase the strength of the input signal. So it gets improved. Then now this signal is passed to my analog to digital converter. What it does means it converts my analog signals into digital value, zeros and ones. If suppose it is, I have given an example of 3-bit, right? If it converts into 3-bit, my analog signals will be represented in terms of um, values from 0 to, yeah, yeah, yes, yes. Some person were trying to ask the question, yes. Okay. So this is the process of your front-end electronics, right? We will see in elaborate about your analog to digital converter in your digital signal processing module. Can I proceed to the next slide, or do I want to repeat any points here? Okay. If it is no, then I proceed to the next point. I hope that you people now understood how you get an signal, a digital signal that can be processed, that can be given to your processor from a sensor, right? Okay. Now I have got digital. I have got a digital signal. Okay. What this digital signal processing does. Okay, you know what a signal? Signal is nothing but it is a function that conveys information about a phenomenon. So with respect to your electronics communication, we refer it as a voltage varying over time, or current that carries your information. So signal processing is nothing but your ability to modify the signal. The signal may be obtained in from your sound, image, or whatever thing, right? In your digital signal processing, what you do is you try to optimize the signal by applying mathematical and computational algorithms. Okay. Why I need a digital signal processing? Can anyone give me an example where have you seen the application of digital signal processing in the real world? Why I pose this question means I know there are people who have electronics backgrounds, so they can give an example where you apply this digital signal processing in day-to-day life. I wait in the chat box, or you can unmute and give your response. Audio compression, yes. Video compression, yes. Good. Digital image processing. Okay. Do digital signal processing can be applied in our phones? Seismology. Okay. Okay, even radar also USDS. Okay, fine, right? We will discuss all this in elaborate in upcoming modules. This is just an introduction. Okay, right. Getting back. Okay. Um, what is data transmission? Right now, I have got a. I have sensed from the sensor transformed to electrical energy. Then, as the electrical energy is weak and it has noise, I removed the noise, amplified the signal, and then converted the signal into digital. And then I have applied this digital signal for into DSP and I have processed. Now I have to transmit, right? Now I have a digital signal which is ready for transmission. How to transmit? When you want to transmit, you have to think about two things. The first is how to transmit and by through which channel I want to do this transmission. So when coming to the question how to transmit, what is transmission? It is nothing but transferring your data between two electrical devices. So you can be analog or digital format. We will discuss about your digital format. How to transmit? It can happen either parallel or serial manner. What is parallel? What is serial? See, let us take, I have 8-bit data, right? If in parallel transmission, what you do, you parallelly transmit all the 8 bits from one device to another device. You need to have 8 wires. In serial transmission, you transmit 1 bit at a time in a sequence, right? That is what serial transmission. See, in serial transmission, either you transmit in serially, in parallel, you transmit all at a time. If you go for serial, again you have two types, synchronous and asynchronous. What is synchronous and what is asynchronous? Synchronous means you along with the data you send your time so that both the system get synchronized and you transmit your data. In asynchronous you transmit only the data and you set give a special indication to indicate the beginning and ending of your data. See, all these informations or preliminary things to understand your electronics behind your IoT, right? Okay. Now, what is the transmission mode I have? The transmission mode can be either simplex, half duplex or full duplex. From the picture, you can tell what is simplex. Simplex means one-way communication, right? Half duplex means two-way communication is possible, but at that time you can pass information in only one way. What is full duplex? You can pass information at a time parallelly by both the sender and receiver. Okay. Now I have a question. What kind of transmission is my email? For my email, email is what kind? Is email half duplex? Okay. Any other answer? Any other answers? Can I have email as an asynchronous transmission, and can I say it as an asynchronous or synchronous transmission? Your email
Asynchronous transmission, ma'am.
asynchronous transmission. Okay. May I know why you justify it as a half duplex? If suppose I vote for
Ma'am,
full
it's a full
duplex,
duplex, ma'am.
yeah.
Ma'am, it's a full duplex type communication.
Okay, fine. Okay,
Ma'am, because
because
this,
yeah,
ma'am,
yeah,
because there is a SYN and acknowledgement flag that creates a connection between the two computers, like TCP type of communication.
okay. So now we are interacting, right? What kind of communication can I have this online class that if you can also consider this as your video conference, right? What kind of communication this is?
This is UDP type of transmission.
No, no,
Full duplex,
I'm not
ma'am.
getting into the reliable or unreliable mode of communication. I'm not
Ma'am, it's
getting
full
into
duplex.
trans
Full duplex,
synchronous or
ma'am.
asynchronous. Yeah, it is
Full
full duplex. It is asynchronous or synchronous. Is it synchronous or asynchronous? Okay, I leave it for you people. You find and tell me the online class that we are doing. You can have this as an example of video conferencing, and you just tell me what kind of transmission it is, synchronous or
Ma'am,
yeah.
I think it's an asynchronous, ma'am.
May I know the reason?
Ma'am, generally synchronous defines by the clocks, ma'am, clock speed.
Mm-mm-mm.
So that oh,
Yes.
oh, but the- but-
Okay, I think the voice is breaking. Okay, let me have it as a discussion. I vote for synchronous, and your classmate voted for asynchronous. We will discuss and come with the conclusion, right? Okay, I will move for the next slide. Choice of channel. Now, okay, now I decided what in which way I'm going to transmit, right? Either parallel or serial, and which mode of communication I'm going to take for my transmitting of data. Then I have to make a choice of channel. What is channel? Channel is nothing but the medium for communication. Whether I go by a wired medium or guided medium or wireless or unguided medium, right? So which way I'm going to transmit. If it is guided, you have twisted, coaxial and fiber optics. I have just given the pictures of them for reference. We are not going to depth of that. We will, if anyone possible, they can give an example where you use your coaxial cable. We have cable connections in our home, right? That we use your coaxial cable, and fiber optics is meant for long range communications. If
and
you have, yeah, yes, yes, proceed.
ma'am,
ma'am,
coaxial is
coaxial
used
cable is for TV channel transmission.
Yes, yes, you're right. Good, good, good. And where we use your twister?
Five,
Ma'am, in RJ45,
Yeah.
RJ45 means broadband cable,
Okay.
Ethernet cable, Ethernet.
Yes, yes. Okay.
Twisted is used in telephonic communication, ma'am.
Fiber optics is used in.
Twisted is used in telephonic communication, ma'am.
Yes, yes, twisted is used in telecommunication. Good. Now we will, and now from now onwards, our focus will be on your wireless, right? And in your wireless, you can go for radio waves, microwaves, or infrared. Now, like you give an example for guided. Can you give an example for unguided also? For
Ma'am,
satellite
ma'am,
communication, okay, I post it as a question. You people give it as an answer. For satellite communication, which one I can use?
Ma'am,
microwave, ma'am,
ma'am,
micro.
Pardon? Okay, I will move for the chat box. You can give the answers over there. For satellite communication, which I can use? Yeah, it is radio waves. Good. And for microwaves, can you give me an example? For microwaves. Okay. And for infrared, yes, for mobile phone. Okay, towers. For infrared, our TV remotes, right? Okay, good. So, oh, yes, you're right. Okay. Okay, that's what I have listed some examples for your waves. So all this are for preliminary understanding for okay.
ma'am,
Then yeah, yes,
ma'am, which one would be suited for long range transmission?
for long range transmission we use your radio waves. I if I'm not wrong, that is for long range frequency. Uh, we use your radio waves.
Okay, ma'am.
Okay. Then comes, okay, now I have transmitted my data, right? From the sense to two, I have transmitted my data. Now, what is backend data analysis? Now I have my data. What to do with data? Before we see data analysis, we will just see one small discussion. That is, I have a collection of student test information. If I want to find what was the how the performance of the student, I need to make some sort of analysis. What kind of analysis? I will find what is the average mark, what is the minimum mark, what is the maximum mark, what was the pass rate, right? At least that minimum mathematics I do to do that analysis. In the same way, in IoT, if you have your data, you need to perform analysis to get you meaningful information. What kind of analysis I can do? In general, you do descriptive analysis. What is descriptive analysis means? From the data you collected, you can tell me how the things were happened. Say from the okay, from the weather information of past 10 years, I can say for every 2 years there were heavy rainfall. Like that, I can make a prediction from the past information. I can analyze and tell. And what is diagnostic analysis? What was the cause for the particular problem? That kind of analysis you can make up. For example, I can from the log, right? From your system log, you can understand where the fault it has went, right? Then predictive analysis. You make a prediction about the future from the data you collected on the previous. The same weather data can be used. From the data you collected for past 10 years, you can make a prediction that how it may be on the next coming year. That is predictive analysis. What is prescriptive analysis? You can combine all these three and you can make a plan. That is your prescriptive analysis. And we will discuss that in elaborate in coming session, how you do this, how you design your data model. We will discuss at later. So as of now, why you need data analysis? To make some logical decision or prediction, you go for your analysis. That is why you do analysis in your IoT, right? Now, we will look an example for that, remote patient monitoring. Here you have some new terms for you. Body area network. What is body area network? I can implant sensors inside the body to monitor my blood pressure, glucose level, heartbeat, right? I can implant sensors inside the body, as well as I can use sensors as a part of my cloth that is outside the body, or I can place it as a separate accessories along with me as like a watch, right? Okay, and this watch comes under your wearable devices, right? Okay, now what happened means this sensors, right? This sensors will communicate among themselves. They will sense your body condition, and they will transmit this information uh, through a specially dedicated device, right? Through low range communication. And this device can store the data. What you have a term called cloudlet. I will explain you what is that cloudlet means, right? This this dedicated device will store the information in the cloudlet, and for further processing it will pass through internet. It will pass it to your remote area where your doctor may reside. There an analytics will be done periodically. This information will happen. They will do analysis, and if they find that something is deviating from the normal condition, that will be given an alert to the doctor, or it as well as to the emergency centers, right? Now what is this cloudlet? Why I picked this example means I want you people to get introduced with certain terms, so I picked that example. What is this cloudlet? Have you people used Google Drive? I'm moving for the chat box. Yes, reviews or examples for descriptive analysis. Good. Yes, okay, many of them have, okay, most of them have used Google Drive. That's good. That means your Google Drive is an example of your cloud environment. I think we have discussed this topic because from the you are not spending your packet money for the storage, right? And you can pick your files from anywhere when you want it, right? So the cloud is nothing but you have a resource, and if you can use that resource either by paid or some free service. If they provide free, you can use it, right? Okay, so now what is this cloudlet? The cloudlet is nothing but it is a miniature cloud, right? It is a miniature cloud that is present on the edge side. What is edge? Now you want, now I have told you another term. What do you mean by edge device? The edge device is nothing but the device, right, that is present at the edge between the outside world and the inner network, right? This cloudlet, if I have a miniature cloud at the edge device, then I term it as a cloudlet. You have this type of cloudlet in certain applications to store the data, right? So so this is a good, very good example for your backend data analysis, right? Shall I move further?
Ma'am,
Yes.
um, yeah, actually said that the cloudlet, can I understand it is in this way? Actually, the cloudlet is a temporary storage area to transmit information to the actual cloud. Is it correct?
It is a temporary. It is a temporary storage
Temporary
area
storage
to transfer.
the information to the actual
Okay.
cloud.
Okay. Yes, you can understand in that way also.
Okay,
And the
ma'am.
one more thing is, you have to make one point. It is mobility. This storage is mobile. It is not at a constant place. You can move it. If
Yeah,
you
yeah.
if you move your device, that the storage can also be. It is mobility mini storage. You can have that
Oh,
understanding. Yes.
okay,
And,
ma'am.
and, and as you have posted the question, I will add one more point. There is one concept called data retention. That is, to which period of time I have to retain that data within me. Right? Okay.
Okay, ma'am.
Uh, now, okay. Now comes what is SOC, right? Now, we will see a small clipping and then we will get back.
மேம் சவுண்ட் அவ்வளோவா கேட்கல மேம்.
Ma'am, ma'am, there is no audio, ma'am.
Yes?
மேம் ஆடியோ கேட்கல மேம்.
கேட்கலையா? Okay.
கேட்கல மேம். ஃபர்ஸ்ட்ல இருந்தே கேட்கல.
Oh. So previous also you were not able to hear?
எஸ் மேம்.
Yes, ma'am. Yes, ma'am, of course.
Okay. Okay, fine. Okay. I will post you the videos, right? I will post it in the classroom and your Moodle site, right? So I just want to convey what is system on chip. It is simple, right? From the picture you can say if I'm able to incorporate my processor, memory unit and the ports that is meant for input output communication all together in a single chip, you call it a system on chip, right? Okay, why I need to know about this SoC? This made your IoT as a possible one because it is highly okay. Do you think your IoT devices are constrained by any factor? Say by size, memory, power, right? Do you agree with this? Your IoT devices are resource constrained because they can they operate on battery. Most of the times they operated on battery. Then if that means if you place it in remote area, it operates on battery. Then again, it is a memory constraint. Your IoT devices on its own, they don't have much memory. In the onboard, you have only limited memory to read your data and transmit that data, right? You have to consider all these constraints. Okay. Now, we will see about how this, okay, now we have seen so far what all we have seen, how physical quantity is converted into electrical and electrical is transformed into your digital signal. Then after processing, that information is passed transmitted over the medium. You do some backend analysis, right? And how, okay, how these things can be happen means I can use SOC for my IoT, right? Now we will get into deployment. Before I get into deployment, now it is, now the terms we are going to use for this deployment is completely different from what we have discussed so far. So I just want a recollection of what are all the basic components you remember when you hear the word IoT. After that, I will get into this IoT levels because here you discuss the terms in a different way. I tell you why you discuss in a different way. Okay. What are all the things? Okay, actuators needs only. Okay, many has been posted. Okay. What are all the things you remember if I say an IoT application? I list it out. I will remember sensor actuator. I started. Okay. What are all the things you remember? This is at the lower level. Okay, you remember home automation. That's good. Gateway, cloud, sensors, then some form of there should be some form of communication, right? That could be a low range communication and your high range, yes, communication channel. You have come up with that, right? And you will have some data analysis, right? Okay, hardware. Yes, without hardware and actually without power, there is nothing. User, yeah, of course, it is for user, internet access. Right, with this input, I will move further. Okay, too early for the class. Okay. So when I get into the IoT levels, I will introduce you one term. See you um, all your people could have heard of outsourcing, right? If I want you just think it of a company is involved in textile industry, right? If they are involved in textile industry, it is not that they should be having field to get the cotton. They should be having industry to get it your yarn, right? All those things it's not needed. They can outsource it, right? In the same way, the way you have all the things what we have discussed, that is from sensing to data analysis and developing your application on the local, or you're outsourcing with the cloud, your deployment level changes, right? To understand this deployment level, first we will see some basic terms. You know, where by the time you are well introduced with your device is nothing but the ultimate thing, your sensor or actuator, that is meant for sensing and monitoring, right? Now what is this resource? It represent your software component, right? The software component that is required to store your sensed information, right? And that helps to control your actuator, and that helps to access your net helps to get access to your network. That software component, from now onwards I will use the term resource. What is controller device? It is an platform dependent service run on any device, right, to interact with your web service. So what is this web service? Web service is nothing but if two electronic devices communicate with each other through your World Wide Web, then you call it as a web service. Why I need web service? Because if I want to post my data in a portal, in a Twitter, or I want to send it to an app in the in my phone, I need to access net, right? So I need a web service. So this controller is responsible for initiating that web service, for sending and receiving data through the web service. Then what is database? As we know, it is storage of data. The place where you store your sensed information, you call it as database. Either it can be in your side, that is on the device side, you call it as edge side, or on your cloud. As you seen, what is web service? It is meant for connecting electronic devices through your World Wide Web. Analysis is nothing but it is again a software part, right? That the software portion that helps you to analyze your data and generate a meaningful report from that data. That is your analysis component. Then application. Based on this analysis, you will pass information to your application. I tell you an example. I have sensed information from my light. Okay. Then from the analysis, I came to know that already there is a high intensity. So I want to minimize it. I make that decision. So I want to pass this decision to the application. So the application may be an app running on the mobile user, right? User's mobile. Now I may off the light. That is the decision I may do. So this is the application. So this is the general terms we will be using for the to understand your deployment. So you have 6 level of deployment. In the first, say at any point of time, if you have doubt, you can unmute and ask it. In the first level, see, throughout this deployment, the basic idea is only one. whether you are deploying all these components, right? All the components of this IoT system in local or cloud, or which part you are going to outsource or place it in your cloud, right? And in your local, how this components interact with each other, right? In the first level, you can consider your IoT system as a single node which senses your data, right? And it is mainly used for your low cost and low complexity solution, and all the things you can perform on your local site. That is, you don't use your cloud. You should not understand that I am not using my internet connection. Of course, I have to use my internet connection, then only it is IoT. The thing is, I am not using the cloud for any storage. That is the basic understanding. Here, you will not see any low range connectivity or long range connectivity. All these things we discussed are in terms of your components. If you people were clear, I will move with the example. Otherwise, I will repeat the previous slide. Okay, I will check the chat box. Shall I proceed with the deployment, or I want to repeat the points before getting into the levels? You can. Okay, fine, thank you. Okay, that's good. Okay, so we will take a simple example. I have to regulate my air conditioner, right? And this application is in my mobile, right? I have to regulate the air conditioner is the application, and to sense the status of my air conditioner, I am using a temperature sensor. The sensor sends the value, right? It is not going to use any cloud to store the sensed data. You for further understanding, you assume that all this analysis are done in your gateway. What is your gateway? Your gateway is the device that connects your local with the internet, that is with the outside world, right? It could be your router, right? It will be your router. Okay. Now this data collection and analysis is done there, right? And based on the analysis, the input will be given through the net, right? The input will be given through the net to your application, and it will receive the response and it will act accordingly. You don't get confused why I don't have actuator here, right? It is for understanding, right? So in a single in the first level of IoT deployment, you will not use any cloud. You will do the data collection, pros analysis, everything on the local side, and only for communication you will use your internet. The next level, in the next level, right, what you do means you place your data. See, from the picture you can see, you place your data in the cloud, right? You place your data in the cloud and you do the analysis here, and that analyzed information will be sent from the cloud to the app. At the end, I will give you a simple example for that, right? Okay, here you might have seen one word called REST, right? You don't worry much about that. It is a protocol, right? That is meant for communicate. That is an application level protocol that is specially meant for your IoT, which we will discuss in elaborate later, right? Okay. It is almost similar to your HTTP, but it is lightweight. Okay, the same example, the difference is, see, I have used my cloud, right? I have used my cloud for storing the data. When I will use means if I have large volume of data. For example, initially I will be monitoring temperature um, once in 2 minutes. Then I can go for the previous example. I don't want to store it in the cloud. If I'm monitoring data for every 5 seconds, I will have voluminous of data. So I can go for cloud. Here, you can do your data analysis partially in the local. You store the data in the cloud formatting, but you can do your will do your analysis in the user side, that is on the front end. Next, the third level. In the third level, the architecture is same. Again, you store your data in the cloud, but here the data analysis will not be done on the local side. The entire data analysis will be done on your cloud side. See, the entire data analysis will be done on your cloud side. This is your level 3. For level 2, smart irrigation system can be taken as a very good example for your level 2. Okay, level 4. It changed. So far, in level 1, 2, and 3, we were considering that you have a single node. If I have multiple nodes, right? If I have deployed multiple nodes to sense my environment, what I do? That is your level 4. Each device, right? Each device will sense the data and store it in the cloud, and you have one node called observer node. This observer node will subscribe and receive information. Okay, as you, what is this subscribe and receive information? You could have heard the term subscription. If I subscribe for a newspaper, what will happen? Whenever there is an issue on that newsletter, I will get a mail for me, right? That is what generally we mean for subscription. In the same way, right? If I am interested in certain scenario, for example, if I subscribe for, if the temperature is greater than 30 degree, I have to be intimate. I'm interested in temperature. Whenever there is a drastic variation in temperature, I'm interested in that event. If I subscribe for that, this observer will receive information about that subscription, about that data, right? That is what your subscriber. Usually you will be using your MQTT protocol for the subscription model, which we will be studying in detail in your third module. Okay. So in the level 4, when you use multiple devices, you normally go for your observer node. And this point, I want to make it one thing clear. It is not that you have to use your MQTT only in the level 4, right? But it has to be used if it is level 4. Okay, that is the difference. See, in the example, I have multiple sensors. The data are stored in the cloud. The analysis is done over there. Then the level 5. In level 5, again, I have multiple nodes. I have observer node. Apart from that, I have one coordinator node. What is this coordinator node? It coordinates information from your multiple points and pass the aggregated data to your cloud. This kind of application you can use in the remote places. For example, if I have deployed sensors in my forest for forest fire detection, it's not that all the sensors will pass the information. The sensors will coordinate among nearby. The aggregated or the collected information will be passed by one node, that you call it a sync node, to your cloud. I'm not getting into that. That is an example of your wireless sensor network extended to your IoT. Even in this example, we can pick it. There will be a coordinator and the aggregated information will be sent for further processing. In the level 6, you consider each node as an independent node, right? Each node as an independent node, and you have a centralized controller, and that will aware of the status about all the node, and this node will pass the control to your node. You don't have coordinator. The difference is in coordinator will collect information from all the nodes and it will pass. Here your centralized controller will collect information and it will handle each of them separately. That is your next IoT level 6. This is used in your weather monitoring station. Okay. At this point, I put a hold. Before I get into this, I want to know if you people were comfortable with the deployment. If so, I will proceed further. I couldn't see any responses. Okay. Please, okay, short summary of deployment. Fine. Mm, you have 6 levels. Okay, how I'm viewing, the deployment is being viewed means based on the services you deploy it in the local and in the cloud. What is local? In the sense, the local is nothing but the area where you want to implement your IoT, right? Okay, in the first level all the processing will be done on your local side, right? Only the communication will be through your internet, because as you have a mobile app, you have to use your internet, right? You are not using any cloud. Everything is done on your local side. That is your first level. In the second level, you store your data in the cloud, right? That is your second level. In the third level, okay, I will go for the slide so it will be easy for following. Okay, see, in the first level, everything, you just focus on the example, everything is on the local side. In the second level, you store the data in the cloud, but you do the analysis on the local level because it is limited. So you do your analysis in the local. If you do the analysis on the cloud and you don't do any analysis on your local, then it is your level 3. And all this level 3 levels focus on single node. What if I have multiple nodes? If I have multiple nodes, then that comes under level 4. When you have multiple nodes, you have one thing called observer node, and that observer node will register for the interested events to get the notification, right? That is your level 4. Here, these nodes are not independent of each other, right? They may be dependent on each other. The next is your level 5. In the level 5, all the in the level 5, you have a coordinator. The information will be, all your data will be collected to the coordinator, and your coordinator will pass the information to your cloud for further processing. The next level is your level 6, where all this node are independent of each other, right? And you have a centralized controller and all the communications happens to your centralized controller. That is the summary. If it is single node, if it is for the first 3 levels, you have single node, and for the next 3 levels, you have multiple node. For the first level, you don't use cloud. For the second level, you use cloud only for storage, and in the third level, you use cloud for both storage and analysis. In the fourth level, you have observer node, and in the fifth level, you have a coordinator, and in the sixth level, you have a centralized processor. This is the summary. Okay. Shall I move further? Okay.
Yes, ma'am.
Okay. 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 Now, okay. What is it? Before we discuss about what is it, we will have throw some light on the power constraint of your IoT device. Now we know that any electronic device need power to perform, right? If you are going, it is not possible that always to give a physical mean of power through a device. So we will use batteries as a backup for power supply, right? With this introduction, I just posed you a question. When there is a power supply for a device through battery, it is automatically have power constraint, right? And you expect that battery to withhold a long amount of time. Uh, Being IoT emerged, you have a field called wearable devices. Wearable devices means see in your cloth and your watch, right? Everything, whatever you have in all your accessories, you can include your IoT. That is, you can include your sensors, right? Along with the sensors, you also want to include a module, right? That module is capable of transmitting and receiving information, and that module is capable of generating power supply or providing power supply for the operation of device. I repeat the point again. There is one field of IoT, that is your wearable device. This is applicable for all, but for understanding and for explanation, I am picking the wearable device concept. So the wearable device means a device that you can use it as a part of your cloth, or you can have it in your bodies as any form of accessories, right? Now this device should have a capacity to transmit and receive information, and it should have a way for generating power, right, for the working of the device, right? If this is the constraint, if I put a battery of this much size, a bigger size, will it be suitable for wearable device? No. That means I should have some way, right, like a thin paper. I should have a battery which is flexible, thin, and capable of holding power for large amount of time. Even it may have a capacity to grasp power from the environment, right? I should need such kind of batteries to so that I can make use it of in wearable devices, right? One such kind of battery is what you are viewing. This is your printed battery, right? This is your printed battery, uh, and I want you people to have a read. You don't want to get into much deep. You just have a read on this website, because they have given some basics about the first printed battery, right? You have it as a home assignment to appreciate why you need such kind of batteries and how this support for your IoT devices. With this, I like to conclude our today's session. Before I conclude, I just give you a summary of what we have seen so far, right? So we started from an introduction that how a sensor data, how a sensed information will be passed. So first we see how the sensed information is transformed to electrical energy. An example we see for your microphone. Then from the electrical energy, how it is transforming into your digital signal. What are all the stages it's move on. First you remove the noise from the weak signal, then you amplify the strength of the signal, then you pass it to your ADC to get your digital signal. That means digital values, right? And then this digital values are being can be processed by your DSP. And now how to transmit this data, either through serial or parallel transmission, or through which mode of transmission, full duplex, half duplex or simplex, right? Okay, then which medium I can pick, guided or unguided, that is wired or wireless medium. So I have transmitted, so why I need to do a backend data analysis, right? And what is SOC? We have seen system on chip, and then we discussed the deployment levels of your different levels of deployment of your IoT devices, and then we ended with your battery, that is your power constraint. Now I have given a summary. I expect any one of you to narrate what we discussed today, or you can just post it in the chat box. What are all the things we did, what you learned, no, what are all the things we discussed, not what you learned from today class. If it is already, if it is not new for you, the concept, you need not to post it. If the new thing that you learned from today class, you can post it in the chat box.
Actually, I had one query.
Yeah, yes.
Ma'am, which is faster, the serial one or the parallel mode of communication?
Actually, parallel mode of communication will be faster, but due to advancement in the processing, we go for your serial mode, because parallel mode you pass it all the bits at a time. So it is the faster mode of communication, but nowadays we use only serial mode, because for parallel mode you need multiple wire, that is costlier, right? So you go for your serial mode. Now if you see your laptop, all your commute ports will be a serial port. In long back you had printer parallel port.
Okay, ma'am. But ma'am, I also had one query. If the receiver is slower than the transmitter, then there may be a chance of package loss. That's why they use serial, I guess.
Okay, maybe your point may be an add-on.
Okay, ma'am.
Am I answered your question?
Yes, ma'am. But
Yes.
okay, ma'am. Does the all SOCs use the same type of communication as a laptop?
I couldn't get all the.
The system on chips uses the same types of communication protocols as a laptop.
No, actually communication protocols, we have not touched it. You have different types of communication protocols, UART, GPIO, right? I2C, you
Yes,
have,
ma'am.
we have not touched that. The reason is I'm just starting so that I can hope go along with all the stream of people. We have not touched your communication protocols. Probably, maybe if you are interested, I will show you how your IoT devices, where this communication protocol resides and what are all the type of communication protocols. I will post it in the coming days. But I have not discussed that communication protocols. No, not a single way. You have multiple varieties of communication protocol. I just given the basic thing, serial and parallel transmission.
Okay, ma'am. Thank you, ma'am.
Okay. Yes.
Hello, ma'am. Ma'am, what are the filtering techniques involves, ma'am, to remove the noises from the signals?
Filtering techniques.
Yes, ma'am. How to filter that specific signal from noises, ma'am?
Okay, that is much into the electronics that we will discuss elaborate in the next sessions, right? As of now, I will give you an high level abstraction. The example we picked and showed is your low pass filter. That is, I set a frequency range, right? If the
Okay.
signal frequency is below, then that threshold I will allow it to move, otherwise I will cut it off. Why we have picked low range low pass filter means normally the signals generated by your sensors is a low range communication, low frequency signals, right? So
Okay.
we use your low pass filter over that.
Okay, ma'am.
I think one of your friend have posted low, high band, stop, band pass, varieties of filter pass. I have not gone into depth. Okay. Okay, many have posted cloudlet deployment levels. Okay, fine. Then in the next session, we will be discussing about sensors, types of sensors in detail, signal strength, all those things in detail. And from that onwards, you need some electronics background. Um, so I will post some material, some basics materials needed for the class, and I will be moving in slow so that I can go up with all the persons, right? Okay.
I'm actually I had one query.
Yeah.